Hello guys, in this new tutorial, it's a little experiment. A user on my Discord server asked to the community a way to make a geometry nodes workflow to implement a straight skeleton feature. I read some documents about it, but without going too much into depth, I decided to try a simple technique. As the definition says, the straight skeleton of a polygon is defined by a continuous shrinking process in which the edges of a polygon are moved inwards parallel to themselves at a constant speed. To do this, each vertex needs to be moved related to the angle that it has from the beginning, and in a certain time, when two vertices are colliding, it borns a new edge from this collision, and in the end of the result you get a single line passing through the entire polygon, getting the final mesh we need. So in this tutorial I'm going to create a simple technique to solve the problem of this user, and you're going to be able to download this on my Gumroad page. So let's get started. I'm working in Blender version 4.1.1, and the concept behind this tutorial is this. It's not a tricky idea. So we have our polygon, a mesh if you want. It can have multiple faces. We don't care because we are going to dissolve these edges. Next we are going to extrude all these edges on the boundary and move the vertices along the opposite direction of the normal of the original vertices, and repeat the step until the collision of these vertices. And because sometimes you will not have a perfect collision between these vertices, we are going to use the merge feature to be able to merge in a certain distance the vertices to get the correct final result of the shape. In addition, we are going to move these final vertices up to make a depth, like a roof, for example. So let's jump into geometry nodes. But before, we are going to create a simple mesh, like a plane, to test our idea. Now we can go in the plus button, general, and geometry nodes. We can create a new geometry nodes, and first we need to dissolve all the unusable edges. So to test this idea, I enter in the edit mode, select a all, right button, subdivide twice, and also I press K for the knife and trace a little line like this. Next, I'm going to take some vertices and move up a little bit or down, because what I want is to have an entire flat surface to have the correct normal of the vertices. So first we can dissolve the unused edges, and for this we can use the edge neighbors. It counts the faces connected to each edge, and as you can see we have edge connected to only one face, like this edge, this edge, this edge, but these edges inside are connected to more than one face. So if this face is greater than 1, we need to delete the faces. So we can use the delete geometry nodes. We can filter with this selection and change the domain to edges. This way, if I exit from this edit mode, you can see we have only the boundary of the shape. We can select all these nodes, Ctrl+J to dissolve edges. Next, we need to move the vertices on the same plane. So if I take these and move up a little bit, we don't want these, we want to have all in the 0 position on the z-axis. And to do this, we can add a set position node, link here, and take the position, the actual position, separate it in the 3 components, and recombine these, leaving the x, the y, and leaving 0 on the z. Link these to the position, and voila. Press H to collapse these nodes, select all these nodes, Ctrl+J to move all on the same x, y plane. Next, we want to save the normal for these edges, for these vertices, because we are going to use this normal information to move the extrusion inwards. Okay, and to do this, because we don't have an information of the normal for the vertices, but we can have this information using the control points of a curve, we can convert this mesh in a curve. So we can use the mesh to curve, and next we can use a store name attribute to save what? The vector of the normal information. But keep in mind, we could have a wrong normal in this plane because we moved the vertices from a different location of the Z, etc. So to be able to have the correct normal on this plane, I suggest you to not use the normal, but use the tangent information that we are sure to have in the correct direction for all the control points, and using a cross product with the negative z direction, so a vector that are going down on the z, we can have the perpendicular vector from the plane on which the tangent and the negative z vector are located. If you don't know how the cross product works and what is, I leave the link in the description and here if you want to see the video about it. So with this perpendicular vector, we can have the correct normal of all these vertices. And I remember you, if you use in this order the tangent as the x-axis, the negative z vector as the y-axis, you will get the direction of the positive z as the perpendicular vector result. So take these axes, the x, the y and the z, and this is the same result of the cross product between the tangent and the negative vector in this case. So as you can see, if this is the x and this is the y, this is the z, rotating this axis here. So this means that the first vector in the cross product needs to be the negative direction of the z-axis and not the tangent. So I need to link the tangent here and set as the first vector the negative z-axis and delete this normal. Next we can link this to the value and set v normal as the variable. Select all these nodes, Ctrl G, F2, save normal on curve. Now that we have the normal of all these edges, we need to fill this curve to have a practical face, and to do this we can use the fill curve using an n-gon. There's no problem for this, but there is a problem. If I link these to the final geometry, you can see while the converting operation from the curve to the mesh, I lost all the attributes I stored. So I lost the v underscore normal attribute. So to restore this information, we need to take from this original curve the simple index node, selecting here the vector for all the points, and take the stored name attribute called v underscore normal for all the indexes of our curve, and transfer this information in a new store name attribute inside our mesh. And in this way I can transfer the information from the original control points and the future vertices of the mesh. Link this here, setting the same variable name like v underscore normal, and let's see the face orientation. The face orientation is pointing up, as you can see with the blue color, but this is wrong because next, when we are going to extrude the edges and move them inwards, and we are going to use an height to make a depth inside this shape, this face needs to point its normal down and not up, so not inside the object, the final object, the pyramid, but outwards. So to do this, we need to link here a flip face node before connecting this to the store name attribute. We can select all these nodes, Ctrl J F2, save normal on mesh, and we can start to extrude the edges, but before we need to save the information of the original edges and the not original edges made by the extrusion operation. So we can add a store name attribute and set a variable like v underscore original. Link, change the type information to boolean for each point and set true. And as you can see in the spreadsheet, all the vertices have the same true value on the new v underscore original attribute. Next, we are going to extrude the mesh and in detail the edges of the mesh without any offset this time, and we can duplicate this store name attribute to toggle this value and turn off this value for all the new points created in the same variable. In this way, as you can see in the spreadsheet, we have the original points that are the original vertices on the mesh, and after the extrusion, the new points created needs to not be the original. We can select these nodes, Ctrl J F2, extrusion, and set the original. Now the tricky part. So if I use a set position node and filter only the new created points and offset up, we have an open object. You can see these edges are still open, and we need to move inwards to close this hole, okay, and close the surface. So we can set the edges as open until they merge themselves, and for each step we move these edges inwards inside the mesh. We can ask if there are still opened edges in the mesh. Set these edges as open and use in the next iteration. So how we can save this open information? Like before, we can ask if each edge is connected to one face, and as you can see in this shape, only these 4 edges are connected to only one face and the other not. So we can use a store name attribute, saving Boolean information for all the edges, and using another time the edge neighbors, we can ask if the face count is equal this time to 1. So if I have 1, I can use this in the selection, and at the same time I can link this Boolean filter operation also in the value, because in this case I want for this selection the value of 1, and I can set here the v underscore open. Now, because we are going to move not the edges inwards but the vertices, we need to transfer the information from the edges to the own vertices connected on these edges. So to transfer this information, we know that Blender will try to interpolate the information, so the Boolean value of true. So in this case, for example, if I want to save the same v underscore open attribute in this vertex connected to these 2 edges, we know that Blender will create the attribute inheriting this information from the 3 edges connected. So this edge has the attribute, this has the attribute, this not. But interpolating these, I will get an attribute with the same name. So for this, I can use the name attribute, calling the vopen, store the information inside not the edges but the points, reading the existing of the attribute in what domain? Not the point domain, but the edge domain. In this way, the system will try to get each point, and from each point ask if there is an attribute called v underscore open, and only for this we will set the value of true. And I can show you this existing attribute and the values pressing Shift Ctrl and click on this set position to have the final mesh, and Shift Ctrl and click on this attribute, and as you can see we have a value of 1 on all these final extruding part. I can cut this node, select all these nodes, Ctrl J F2, set still opened part. Now we can drop this set position and hide the face orientation and press Shift Z to see the wireframe. Now what we need is to iterate for the moving of the vertices, and to do this we need a repeat zone. Link the initial geometry here and the final here, linking the geometry output in the group output, and linking this iteration in the group input to have a new attribute we can call steps, and we need to link this geometry inside this still open part. And for each step we need what? We need to move our vertices, filtering only what? The top part of the extrusion, and I will link these in a reroute point and another time in a reroute here, and I want to move these inwards following the opposite direction of the normal. So in this case we can go here, and if you remember, this is the normal for each vertices, but I usually want to move inwards and not outwards, so to create the opposite direction of the result vector of this cross product I can switch these order, so take the tangent as the first and the negative z direction vector as the second to get the inwards result of the cross product. And because we stored this v underscore normal information, we can take it like this, the v normal, and scale by what? By a value we can link in the group input, and we can rename this scale in shift step. This is a distance value, and we can move this up a little bit. It's a single value like this, but keep in mind here we are assuming the curve made by the conversion between the mesh in the curve goes in this direction, okay, in this direction. But if it goes in the other direction, we need a flip check to invert what? The sign of the normal, because if the curve goes in this direction, we would get the normal in this direction and not in this direction. So if we have the tangent in this direction and the z in this direction, we can get this if the tangent goes in this direction, or this direction if the tangent goes in the opposite direction, so in this way. So to do this we can add a simple input socket like flip normal. This is a boolean type, and we can use this in a switch node, changing this to an integer value and multiplying this value of the shift step by the result of this switch, that in the false condition can be -1 and in the true condition can be 1, and link this to the scale. Link this scale to the offset, and as you can see, the first step 1000 millimeters are too much, so I can set 10 millimeter and increase the step, and as you can see, these result here. So if I want to flip the normal, I can use this check, and for each step the last part of this repeat zone is to merge the result. So if I add a merge by distance node here, linking the same selection of the vertices, we can merge by a value we can add in a group input. So in this way we can decide what is the distance, and this is the single value, and we can rename it in merge distance and move it a little bit up. We can select all these nodes, Ctrl J F2, move, select these nodes, Ctrl J F2, merge. Finally, we can set a final height, and to do this we can add a set position node here, selecting what? All the not original vertices, because from these vertices can arise new vertices that continue to not be the original. So I can use the name attribute, select the original points of the mesh, and here I can use a not filter to select all the other, and only for this I can use a combine XYZ node, linking only the Z in a group input and renaming this Z to the final height, changing this to a distance and leaving this minimum value with a negative number, because maybe I want to move up or down. Remember only this information. If you move up, it's okay, but if you move down, maybe you need to flip the entire faces of your object. Why not? We can add this in this tutorial while recording. So we can set single value, collapse this node, select all these nodes, Ctrl J F2, set height, and we can try these. If I put these here and see the face orientation, if I move these down, I need to flip the faces, so we can take the group input, and if the final height is less than 0, we can use these to have a new switch, we can collapse these and collapse these, and if we have a positive values, we want the original, otherwise we want the shape flipped like this, linking these to this switch. We can create a reroute, and in this way, if I go up, we can always have the correct normal of the shape. We can select all these nodes, Ctrl J, faces by the height. I forgot to add this part in the file I shared with the user on Discord. So if you are watching again this tutorial, take this part and add in your workflow if you are going to use it. And a last thing, it is this, to avoid problem of merging. You can see if I increase the step and increase the distance like this, as you can see, the system will continue to go inside also after the first merging of the vertices. So to create a more properly shape to see the issue, I will delete in the edit mode the content of this object, deleting all the faces. I'm going to create a new plane, and I will select this edge and extrude it a little bit like this. And as you can see, if I increase the step, I have here merged vertices, and because for each step the system will recalculate the still open edges like these three and these three, the system continue to set the new position also if I increase this step like this. But after the final merging of the last points, so in this moment, maybe you don't want to continue to move these merged vertices along the interpolated normal between the original two vertices merged together, because maybe this is the final shape you need to have. So to avoid the continuous movement of these merged vertices, we can add another Boolean attribute, so we can call it continue on closed, for example, and this is a Boolean single. We can insert some nodes here inside this selection, so from this extrusion, and here before the set position and the merge operation we can add an end node where we can get the group input, and in the end node we need to link what? We need to link if the continue on closed is true, we need to have a Boolean information, and we need to merge these extruded vertices, so use all these extruded vertices and the new merged vertices by the previous merging operation if I want to continue on closed. So if I want to continue also after the merging operation, I need to set true and select all these extruded vertices, so the first extruded points and the other merged new vertices. Otherwise we need to filter only what? The still opened part of the mesh and not the merged part. So in this way I can link this false condition in a name attribute and select from here the still open part. If you don't understand, I will repeat this better. So now that I have these nodes here, I will explain. So as you can see, if I decrease this step, as you can see, we have stored the information of the still open part here and here. Okay? Next, after the merging part, as you can see in the spreadsheet, we don't have open part, okay? We have a perfect closed mesh. So in this case, with this flag, turn it off, we are saying to the system, we want to continue on closed? No. So please take all the points that are open, no one, and the selected extruded part of the mesh, and the result of this false and true is false. So from this moment, if I increase the step from this number, you can see nothing changes the position, okay? If I increase over 111, but if I set continue on close, I have this true, and then in this switch I want all the points true, even if they are merged, and the selected extruded part of the mesh. So in this case, true and true equal true as the result. And in this way, if I increase this value, these vertices will continue to move along the interpolated normal of the previous merged vertices until the end. So in this way, you can create a shape like this, or if you want to stop before, you can disable this continue. And this is the entire workflow. We can rename it in a straight skeleton, and we can test it selecting this edge, for example, and extruding on the X. And if you have a problem like this, maybe you need to increase the merge distance like this, or decrease the number of the step to understand what are the best values you need to assign inside your workflow. And I repeat, this is not the perfect solution for all the cases, and it doesn't follow the correct instruction of the definition, because as you can see, the final line that describe the shape, the shrinking of the shape, are not parallel to these edges here, or this line parallel to these edges here. So please use these carefully. Maybe in the future I will make a more precise version of this feature. Who knows? So thank you guys for watching this video. You can always download this from my Gumroad page. If you liked my work, as always, please check like and subscribe to my channel, not forgetting to check the bell icon to get all the notification of my new videos, and see you to the next tutorial. Bye!